December 2024. We are Fu News, bringing you catastrophic news from Spain. I'm Mr. van der Wal, and heartbreaking news as Spain has suffered extreme flooding in the Valencia region. Record-breaking rainfall and flash floods have devastated the area, resulting in casualties, extensive damage, and widespread disruptions. The region was confronted with a year's worth of rainfall in just 24 hours, totaling over 300 millimeters of rain. The rain has severely damaged critical infrastructure such as train tracks, roads, and bridges. Numerous vehicles were displaced in the streets, and over 200 people have tragically lost their lives. One reason the flood's impacts were so catastrophic and deadly is attributed to the delayed and insufficient warnings from the government, as well as lack of public awareness about flood preparedness. According to our meteorologist, Demi Imming, who's here with us today, this extreme rainfall event was caused by a cold drop depression at high levels. Demi, could you explain how and why this phenomenon occurs?
Of course, Wester. What we are observing in the Valencia region is the result of a persistent and complex atmospheric system. Let's zoom further into these satellite images.
These satellite imagery show a swirling expanse of cloud cover over the Iberian Peninsula, driven by a nearly stationary low-pressure area. This low-pressure system triggered intensive convective activity, with thunderstorms repeatedly forming over the same areas, resulting in a progressive accumulation of rainfall. But the critical question is, why did this low-pressure system remain stationary for such an extended period? To understand this, we must examine large-scale weather patterns in Europe. Europe's weather is strongly affected by the jet stream, a powerful, high-altitude wind current flowing from west to east. In the case of the Spain floodings, the jet stream experienced a gutta flow event, where a loop in the stream dipped southwards and became detached. This detachment brought a pocket of cold polar air into southern Europe. At the same time, a large, stable, high-pressure system dominated much of the continent, blocking the typical west-to-east movement of weather systems. This configuration, known as an omega blocking event, resembles the shape of the Greek letter omega and occurs when two low-pressure systems flank a high-pressure system. This pattern effectively locks weather systems in place. As a result, the low-pressure system over Spain became stationary, causing prolonged heavy rainfall. The situation was exacerbated by the interaction between warm, moist air from the Mediterranean Sea and the cold polar air brought by the gutta flow. This combination created a stronger temperature and therefore pressure gradient. The warm air rose rapidly, intensifying the rainfall as the moisture condensed. This interaction, coupled with the stationary low-pressure system, ultimately led to severe Spain 2024 flooding. Meanwhile, much of the rest of Europe experienced stable and calm weather under the influence of a high-pressure zone.
Thank you, Demi, for that in-depth report on the recent events in Valencia. Up next, we have an insightful interview with the climate change expert Berna Ekdemir to discuss what these developments could mean for us here in the Netherlands.
Why was this event so catastrophic?
The flooding in Valencia was so catastrophic because people weren't properly warned about the government. They knew heavy rain was coming, but they didn't send out alerts about just how extreme it would be. Many people were caught off guard trying to move the cars or act during the storm, which led to lives being lost. Emergency help also took 2 days to really get started, making the situation worse. In Malaga, 2 weeks later, things were handled much better. The government warned people 2 days ahead of time and evacuated 4,000 people before the storm hits. Police also went around warning people on the streets to stay safe. These steps helped avoid the kind of tragedy seen in Valencia.
And are these floods caused by climate change?
Well, these weather events aren't new and usually happen around autumn when temperature differences are the biggest. However, we do see that climate change really intensifies these types of floods. The Mediterranean Sea is already 1 to 2 degrees Celsius warmer, which leads to more evaporation and more water in the air itself. Drought also plays a role, drying the soil, making rainwater harder to infiltrate. Deforestation to the west of Valencia also intensifies the effects of heavy rainfall, making these storms directly downwards.
And what is the likelihood that these events also happen in the Netherlands?
Well, we live besides the North Sea, so that makes it very less likely due to the cooler sea temperatures and different climate patterns. However, increased rainfall events are very much in our future, which we do need to be better prepared for.
So we shouldn't be too worried about these types of events in the Netherlands. However, in Spain, the people are the most vulnerable. We're now switching live to a local in Valencia.
¿Qué pasó, señora?
No esperábamos que la tormenta fuera tan fuerte. La lluvia está por todas partes. Dios, ¿por qué nosotros?
¿Cómo estabas preparada para esta tormenta?
Lo que pasa es terrible. Lo he perdido todo. Todo. Es culpa del gobierno.
Gracias.
Gracias.
This was Few News. Have a good day.